Hello sir, my name is Rishabh Saxena and I'm a part of Team Vermilion. Our team belongs to NMIMS MPSTME Sherpur. We are a team of 17 people studying in third year BTech Mechanical. We have a past history of one competition which was GKDC 2015. Here are the 17 pillars of our team: the captain, vice captain, 4 students for design and analysis, 4 in engineering and transmission, engine and transmission, 3 in steering, and 4 in braking systems. Here is the CAD model and the basic specifications of our car. The go-kart over here, it has been completely designed by us on SolidWorks. The chases and the positions of everything have been taken into account and have been modified a lot of times, and this is what a perfect model looks like. The basic specifications of our car are as follows. The wheelbase is 1.27 meters, the track width at the front is 1.02 meters, and at the rear is 1.10 meters. The engine that we are using is Briggs & Stratton 127cc, which produces a torque of 7 Newton meters. The steering geometry is 100% Ackermann geometry, and the mechanism that we are using is pivot brake. The braking systems that we are using is hydraulic braking system. The type of transmission is CVT. Vehicle overall length is 1.9 meters and weighs about 85 kg. The CG location is 50-50 and the ground clearance is 3 centimeters. Here are the results of the front impact, side impact, the rear impact and the side impact structures. These tests were done on HyperWorks, and here are some results of it. The results are pretty good, and these ensure that the car is very safe. Here is the front impact structure, the analysis. Here is the rear impact structure analysis. Here is the side impact structure analysis. The overall factor of safety of the vehicle is somewhat around 4. This is the ergonomics part. This will be explained by Animesh Nanavati.
Thank you, Rishabh, and first of all, hello sir. Now I will be studying ergonomics of the vehicle. The elbow angle of the driver will be 120 degrees, and the knee angle of the driver will be 130 degrees, and it will be really comfortable for the driver while driving. And the distance between the firewall and the seat is 3 inches. And also during the collision, the driver will be totally safe. As the safety features, we have added the firewall and the seat. Distance between the firewall and the seat is 3 inches. Now let's start with engine of the vehicle. Engine, we have used Briggs & Stratton engine of 127cc, and it produces torque of 7 Newton meters. And the gross power of the vehicle is 4 horsepower. And this engine is really available. Everywhere, and we have found this engine to be best match for our vehicle. Transmission, we have used CVT, as CVT enhances the speed as well as the acceleration of the vehicle, and it is really efficient. Now starting with the steering system of the vehicle, we are using 100% Ackermann geometry to our vehicle. You can see here that the turning radius of the vehicle is 2.5 meters. The caster angle is 7 degrees, the camber angle is 0 degrees, and the inclination angle is 12 degrees. Now let's start with the braking system of the vehicle. As you can see, we are using double piston cylinder engine, and as the brakes are very efficient, the braking distance we have managed it to 8 meters. Now next part will be explained by Jaideep Bachkaniwala.
Thank you, Animesh. My name is Jaideep Bachkaniwala. This chart shows the failure, mode and effect analysis of our vehicle that we have done on our vehicle. What we have done is we have used a failure mode, we have analyzed the failure mode, and then we have come up with a solution to it. For example, the frame. Let's say the frame breaks. Breaking of the frame is a safety concern for the driver as well as the drivers around him in other go-karts. So in this case, what we have done is we have used proper materials in our, we have selected proper materials in our go-kart, and we have done proper FEA analysis. Moving on, this chart shows us the design validation plan. Basically what this chart What this chart means is whether we have built our go-kart according to our calculations and design. For example, the steering system. We have made sure that all these parameters, for example, the turning radius, they conform to our calculations. Same with the brakes, the stopping distance, and the maximum speed. This is the Gantt chart. This chart basically is a project management idea. This chart shows us the timelines of our design and manufacturing of our go-kart. We start with designing, then we go to analysis, then we have manufacturing, then we have assembly, and finally we have testing of the go-kart. So this is the timeline for all of our activities. This chart basically shows us the cost report of each individual component as well as the total of it all. We have tried to be as cost effective as possible in all our measures, be it selection of materials, designing or manufacturing. The total cost of our go-kart comes up to around 87,000 rupees. These are all the facilities available in our college. We have hand tools, we have lathe machines in our college, we have welding machines, we have drilling machines. So the go-kart will be built in our college itself. There is no need to go outside anyway. Coming to innovation, we have a differential, as Animesh told us, and a CVT. Differential basically enables us to move the rear wheels at different speeds. So it helps us a lot in taking high speed turns. CVT. A CVT will help us to achieve a higher torque as well as a higher speed at the same time. Higher torque in lower RPM and higher speed in higher RPM. In conclusion, I can say that we plan to build a go-kart in the stipulated time, and we are very confident that it will be built within our timelines and ready before the competition. Thank you.